How's it going? I'm at the end right now of module 1 of test number 5, and I am about to move on to module 2. Assuming that I aced module 1, when I go to module 2, I start and we go. That's it. So we're going to see what happens. I'm going to casually crush this with you and hope that you love every bit of it and that it gives you what you want in the form of know-how. Right triangle has legs 11 and 9 centimeters. What's the hypotenuse? I can click on the reference. I can see Pythagorean theorem right here. That's great. I'm in. 11 squared plus 9 squared equals x squared. I'm going to zoom out. I'm going to look for the vertical line, click on where it crosses, and know that 14.213 is the answer. Now, it's definitely not 202, and it's definitely not 20. Now, it happens to be that it could be this or it could be this. Now, 7 squared is 49 and 6 squared is 36, so the square root of 40 is going to be way too small. Chances are the answer is B, but of course, you can absolutely just have Desmos do the work for you. So that is not the answer. That is the answer. Giddy up. Number 2. So here we have a linear function, and we have the graph of it, and it passed through those 2 points. We want to know which one of these is the answer. I'm definitely going to click on the plus and make a table and immediately put those points in. 721 and 925. Now I'm going to create an equation of best fit. Y subscript 1 by touching Y and then 1 before I take my finger off of the Y. Then instead of an equal sign, I'm going to do the tilde, top left corner of my keyboard to the left of the 1. And then I'm going to go, I don't know what that first number is, A, X subscript 1, plus I don't know what the second number is, B. But the cool thing is the line of best fit tells me A is 2 and B is 7. Done. The answer is B. Doesn't feel like a hard module yet. Let's see what we've got. A company that produces socks wants to estimate the percent of the socks produced in a typical week. Let's see. So a random sample of 310 socks produced in a certain week. Based on the sample, it's estimated that 12% of the socks were defective, and we're looking for defective, with an associated margin of error of 3.62%. So it could be 12%, but it could also be 12% plus 3.62%. So it could be 15.62%. And it could be the margin of error in the other direction, 12 minus 3.62. So it could be 8.38%. Now, when I type in percent, it automatically adds the of. I think that's so cool. It's just one of those things. You can see that if I don't put something there, it can't do the math. So it's going, oh man, like talk to me, talk to me. What I care about right now is that the associated margin of error tells me that I can get the amount of defective socks are between 8.38% and 15.62%. Let me see what the question's asking. They're just asking for the most appropriate conclusion. So before I do any math, let's see what we've got. 3.62% of the socks are defective. Nope, that's the margin of error. It's plausible that between this amount and this amount, that's what we're looking for, are defective. We just actually solved that. 12% are defective. That's not taking into account the margin of error. It's plausible that more than that, no way. Cool, the answer is B. Easier than I thought. It looked difficult, but it wasn't so bad. All right. Truck can haul a maximum weight of 5,630 pounds during one trip. The truck will be used to haul a 198-pound piece of equipment as well as crates. Some of the crates are 25 pounds each, others are 62 pounds. Which inequality represents the plausible combinations of the number of 25-pound crates X? Cool. So if I have X crates and each of those crates is 25 pounds, and I have Y crates, and each of those crates are 62 pounds, and the total weight of X crates and the total weight of Y crates, plus the total weight of that 190-pound piece of equipment, has to be less than or equal to, so I'll click right here and go less than or equal to the total poundage altogether, 5630. That's it. Nothing more than that. Any point in here is going to work, but luckily for me, I can kind of see here that as I look at all the answers, I'm going to go 5630, subtracting 190 from both sides, 5440. Trick. They want you to pick these, but they're not the answers. And we also, how do you like that? If we took it as a highlighter question, we said all the 25-pound crates are X, then it'd be 25X, we'd get rid of C and D anyways. And all the 62-pound ones are Y. So really it's between A and B anyways. And then you'd be like, wait, how did we get 5440? But the answer is because you have to take into account the weight of that piece of equipment. And so now you know that it has to be less than or equal to because it has a maximum weight. So the total weight has to be less when you add them all up than the total weight we could possibly have, less than or equal to. But it couldn't be above it. That wouldn't make sense. So the answer in this case is A. Let's keep acing. I mean, this is just a system of equations. So anytime you see a system of equations, you immediately just want to roll right into putting them both in. Only makes sense. In this case, you can see that they cross each other. We don't know where yet, so we'll zoom in. And then we'll click on the grayed out where they cross. -2, -5, the answer is C. That was way too easy. It's supposed to be a hard module. What's going on here? What is the range of these 7? So range is always the distance from the smallest to the biggest. The biggest is 52. The smallest is 23. 52 minus 23 is 29, and that's it. There are other ways to do it, but that is definitely the quickest and easiest in this moment. I like it, and I'm rolling. 2 customers purchased the same kind of bread and eggs at a store. The first customer paid $12.45 for 1 loaf of bread and 2 dozen eggs. Looks like we're going to create a system of equations. The second customer paid $19.42 for 4 loaves of bread and 1 dozen eggs. So watch this. 1 loaf of bread, 2 dozen eggs. I'll go ahead and say a loaf of bread is X and a dozen eggs is Y. And then I'll go ahead and say altogether that costs $12.45. Then we'll say 4 loaves of bread, 4X, and 1 dozen eggs, 1Y. Give us a total of $19.42. If I click on where they cross, I don't even know if that's what I'm looking for. What is the cost in dollars of 1 dozen eggs? Our eggs are the Y value, so it's 4.34. The answer is D. Look at A as a trap. That would be the cost of each loaf of bread. But these are the X and Y values that make both equations work at the same time. So it is definitely the case that this is the cost per loaf of bread and this is the cost per dozen eggs. The answer is D. I'm not trying to go fast. I am just relaxing. Now, in this case, I love that I have another system of equations. I mean, blown away actually by the simplicity here, especially given that it's a harder second module, but we'll see. So here we go, squared, and then plus 15. I'm sure it's going to get harder, don't get me wrong. The question is literally saying, how many points do the graphs of these equations intersect? They never cross each other. The answer is 0. All right, well, we have another system of equations. Not sure what's up with test 5, module 2 hard, but so far we are relaxed. Let me go like this, x squared plus 16x plus 63, and a solution of the given system of equations x, y. Okay, so we're looking to literally see where they cross. We are looking for the greatest possible value of x. So there are 2 solutions here. I'll click here. Here's one solution and here's another. The 2 options for x are -9 and 6. It turns out that, or sorry, -9 and -6. Turns out that -6 is bigger than -9. This is smaller. This is more negative. The answer is definitely -6, and even cooler, I don't know why, because on a harder module, you'd think that they would give you -9 as an option. They don't, but this is the biggest value of x that could possibly be a solution here because there are only 2 values. That is bigger, but in this case, it's definitely A. Cool. On number 10, and we are less than 10 minutes in. This is good. We have line P as a slope of -5/3 and an x-intercept of this. What is the y-intercept? I'd probably go like this, actually. Sounds strange, but I would do it. I'd say -6, 0 is a point. Then I'd go ahead and I'd say y subscript 1, tilde, And for my slope, I would do -5/3 because I know my slope's -5/3. X subscript 1 plus B. I don't know what B is, but now I do. B is -10. So I know the answer is -10, but I could also go like this and go like that, just in case you weren't familiar with the idea of y equals mx plus b and m being the slope and b being the intercept. But in this case, that is definitely cool. There are other ways to do it, but feeling pretty strong right now, and I don't want to slow down because we're moving. And I'd rather help you crush. If you're on the harder module anyways, you're probably ready to do everything that we've got in front of us. How many solutions does this have? Pro move anytime you have a single equation and you're looking to see how many solutions you have is make y equal the left side and then make y equal the right side. The idea is that if they cross over each other once, you have one solution and the answer is A. If they're parallel, then you know that the answer would be 0. They'd never cross each other. And so the answer would be D. In this case, they definitely crossed once. The answer is 1. If they landed exactly on top of each other, the answer would be infinitely many. Exactly 2 wouldn't work if they're both linear. It would have to be a parabola and a line. I feel good about that. Let's rock. Number 12. Oop. Hello, here we go. So number 12. Hey, Lonnie used fabric measuring 5 yards in length to make each suit. Each suit is 5 yards. The relationship between the number of suits that Kaylani made, X is the number of suits made, and the total length of fabric that she purchased in yards is represented by the equation y minus 5x equals 6. They want to know the best interpretation of 6 in this situation. So what I'm going to do is I'm actually going to go y equals, and then I'm going to go 6 to give this a mute.
See for that.
Just my personality. My brain needs a reminder from my computer about what's coming up every 10 minutes. We're good. So here's the deal. I totally just isolated y. And the reason I did that is because I could click here and add a table for that particular equation. And so the reason I wanted to do that is because now I can look at the table and I can think about what's happening. I know that if I have, my apologies, I was muted. It's all good. I'm the type of guy who needs a reminder from my calendar about what's coming next. And so that's what was happening. But let me help you feel great about this. All these are points on this line. X is the amount of suits that are made and Y is the total amount of fabric bought. Now, if 0 suits are made, 6 yards of fabric are bought. If 1 suit is made, then 11 yards of fabric are bought, but it takes 5 yards to make each suit. 11 minus 5 is 6. If 2 suits are made, there's 16 yards of fabric, but it's 5 yards for each one made. That's 10 yards. There's still 6 left over. No matter what, Kaylani purchased 6 yards more fabric than she used to make any of the suits she made, no matter how you look at it. Pretty cool? I'll take it. Boom. Sorry about the mute. We want to know which quadratic equation has no real solutions here. As I said, the pro move for sure is that if y equals the left side and then y equals the right side, the idea is that you can see where the two equations cross. Where they cross is definitely an indication of the solutions. In this case, if I go like this, you can see there are 2 dots. There are 2 solutions. We're looking for no solutions. These are definitely 2 real solutions. There might be imaginary solutions, but a real solution you'd see on the graph. A is not the answer. Now, all I'm going to do is go like this and change this to B because I can. Easy enough. It looks like this hits at exactly 1 point. That means there's 1 solution, which means there's not no solutions. So I'm getting rid of that one. So I'll go now to C. Minus 14x, minus 49, just change this to a minus. There are definitely 2 solutions. You can see that. It crosses twice. It's not C. Let's hope it's D. All I have to do now is turn this into, hold on a second. This is minus 49. All right, there's still two solutions, so this one is gone. Plus 49 plus 49. Either way, they do not cross. D is my answer. There are no solutions. Sorry for the slight snafus, but we're good. We've only gone 15 minutes and we're already on number 14. Let's see what's happening. So we have a situation here where we are given f of x equals 1.84 raised to the x over 4. So this is my graph. It says I have another equation. It can be rewritten, and p is a constant. Which of the following is closest to the value of p? So we need closest to. So the first thing I'm going to do is I'm going to put in this function. 1 plus, go ahead and put that in parentheses, p over 100 raised to the x. So what I'm going to do is I'm going to make a slider. That's why this is here. And when I do, now I can be like, okay, here's 16. Ooh, those graphs look pretty close. It says closest to, so it might not be perfect. So it could be 16. Let's see if 21 is closer or further away. 21 is further away. 46, further away. 96. Oh, let's go. The answer is definitely 16. 16 is closest to the value of p that makes this whole thing work. Love it. All right, here I go for 15. I'm going to go like this. I've got a system of equations again. It's saying this system has no solution. No solution means that they never, ever cross each other. So I'm going to go ahead right now, and I'm going to go 6 plus 7. You know what? I'm going to make our x right now. Interesting. Watch what I do. I'm going to do x and y. And then it's asking for the value of p. So I'll say py. I made wy. And now I'm going to go 7x minus 5y equals 5y plus 11. All I did was say r is x, w is y. I want to know what p is to make them have no solution. Now, the idea as I watch p moving is that I'm looking to see when they might be parallel, because I can tell that they don't have the same y-intercept. So I'm going to go like this. That's enough for me to kind of look at it and go, okay, let me see. This needs to be bigger than 10. So I'll go ahead and I'll click here on 10. I'll change these values. I'll make it 50 for right now. And I'll just hit play and I'll watch it go. And maybe I'll pause it at some point. And I'll just roll. Too far. Bringing it back. It's going nice and slow. It looks like 10 may very well be the answer. Now, I could do a lot of things here. I could zoom out and keep watching it to see, does it look like they never cross each other? It really does. That's pretty cool. I went pretty far out. I'd feel safe putting 10 in here. If you ever were fully in question, you're like, I don't know, then what you could do is you could click on all the intercepts. And the reason you could do that is you could use those intercepts if you wanted to then find slope. Because if your goal was to find the slope, at least that would allow you to do y minus y over x minus x to see if they have the same slope. And if they do, then you know they're parallel, they never cross, there's no solutions, and the answer is 10. In this case, I feel great that it is based on zooming out. So that's cool. I'm going to go like this. All right, so we're given a graph, and then it says the graph of y equals 2x squared plus bx plus c is shown. What is the value of b times c? Undoubtedly, in my mind, the very first thing that I would do is I'd probably go for the equation of best fit. I'd take a table, I'd put a few points in. It doesn't matter how many necessarily. 3 typically does it. I don't mind doing them all. -2, -6. Again, I want to crush this and not be in a rush at the same time, but also do it in a ridiculous amount of time. Like go super fast without going super fast. 0, -6. I'm not trying to do anything fancy. I'm just trying to be on top of things. So now I'm going to take the equation they gave me. First, I'll touch y and then 1 at the same time. So I'm accessing all 5 of the data points that are in that list right there. Instead of an equal sign, I'm going to do a tilde. And then I'm going to do 2x subscript 1 squared plus b x subscript 1 plus c. Sure enough, it is going to solve this thing for me, no problem. And so now I've got b and c. But instead of doing the math, I'm just going to go bc like that. The answer is negative 24. This is amazing in a million ways, truly. I've been pushing this computer hard all day long, and it is moving slow. And it's interesting to see that slight, like, staggered delay, but it's not going to take away from the ability to absolutely destroy everything with ease. So I like that. Probably should have closed some things before I jumped in with you. So let's see. I'm going to go y equals. Oh, interesting. Check this out. I have f of x plus 19, and that is this graph. First thing I'm going to do is take one of the answer choices. I'm going to say f of x equals negative d minus cx. And the reason I'm doing that is because now I'm going to go y equals f of x plus 19. And the reason I care to do that is because if I zoom out, the purple graph, or I'll make it a different color just so it jumps more, the orange graph is the answer we're looking for. Now, we know that we have some restraints. C and D are positive. So we can play with C and D. We have a goal. We need to hit 0, 3, which I'll go ahead and throw on there because I can. 0, 3. And then I'll just label it. And I guess I'll stop there for the moment. I mean, I guess it looks like, I don't know, maybe 0.750. It doesn't have to be perfect. It has to be close enough. So 0.750. And I'm only doing this for the ease of knowing that as I play with C and D, I want to watch everything change. All right, that's pretty cool. So I'm going to go like this, and I'm going to make 10 bigger. I'll go to 40, even though I probably don't need that much. I started going. Okay, I went too far. I'll pull it back. Try to get as close to there as I can. Right now, that feels pretty good. Then I'm going to go ahead and play with this one. Pretty cool. At the moment, this is looking great. C and D are both positive. It looks like the orange graph is indeed the graph that I was given. I feel great about it. A is indeed the answer. Now, if you wanted to, you could totally check them all. But the idea is that as you change things, like for B here, if I make this negative D a positive D, then no matter how hard I try, I'm never going to get to where I want to be, because the only way to get it to move over is to go into the negatives. And so there's no way it's answer choice B. And that's the case for all of these. The answer is indeed A here. And instead of walking through them at the moment, I mean, I guess I should, just for the sake of doing it, because, you know, I get it. This is for your benefit only. So for me to just jump for no reason for time, that would be no good. I can go like this. Let's see. So I can do this. That's cool. Then if I want this to go in the other direction, I'd have to go into the negatives. So B and C both don't work. And then this is D plus CX. And so this obviously doesn't work on both fronts. The only way to make it happen is to be negative in both. So the answer is A. It was the right thing to do. Let's go like this. Number 18. Cool. We got a triangle. AB is the square root of 34. AC is 3. Right off the bat, because it's a right triangle, I'm going to go ahead and access Pythagorean theorem right off the bat. I'm going to say a squared plus b squared equals c squared. I don't know BC. So what I'm going to do is I'm going to call BC x and say x squared plus 3 squared equals the square root of 34 squared. So sure enough, let me go like this and go boom. Come on now. Square root of 34 squared. Oops. That's okay. I'll be all right. There we go. Square root of 34 squared. And sure enough, it at least tells me that this is 5, right? 5 is the answer to this, the unknown. So BC is 5. Now, if BC is 5, I've got to figure out the scale factor between the smaller triangle, which has angle A and the right angle, and the huge triangle, which has angle A and the right triangle. CE is 21. The scale factor from the smaller triangle to the bigger triangle, because they have similarity, is 3 to 24. That's important, small to big. So the idea is you're going small bottom side over large bottom side like this equals, and then small right side over whatever we're looking for, right? So I'll zoom out. I'll look for that vertical line, and then I'll hope that I have a gray dot. If I do, I'm all set. In this case, I don't. So I could do a lot of things here, but I do know that if you think about it, 3 to 24, I'm multiplying by 8. So 5 times 8 is 40. Of course, I'll zoom in. Oops. I said computer's lagging just a little bit, but it definitely looks like it's 40. If I want it to be ultra safe, I could go like this and go 3 over 24. And then I could go 5 over 40. If I get the exact same thing, I know I have the same scale factor. So indeed, I know that the height is 40. Now, it says, what is the area in square units of triangle ADE? Area is 1/2 base times height. The height is 40. The base is 24. So I'm going to go 1/2 times 24 times 40. That was a serious question right there. A lot of moving parts. In this case, it's 480. I feel good about it. Boom, going to number 19. I'll let that computer lag. I am not afraid. Let's go. So here we go. The result of increasing the quantity X by 400 is 60. All right, check it out. I'm going to go X. Excuse me. X. There we go. Plus 400% of X is 60. I'm going to look for that vertical line. I'm going to click on the gray dot, which you get most of the time. And the answer is indeed 12. That was fun and easy. Let's look at number 20. Ooh, baby. All right, I've got a circle with a center C, and it has the coordinates HK. Then I have a point on the circle that has coordinates H plus 1, K plus the square root of 102. Interesting. ACB is a right angle. Well, okay, here's another hard one for us. So first thing I'll do, I guess, I don't really want to do this, but I'll do it just to do it. I know that H comma K is the center of the circle. And I'll go ahead and pick values for H and K. Maybe I'll make H5, K3, just to do it. Then I'm going to go ahead and I'm going to say H plus 1, comma, K plus the square root of 102. Now, when I do that, at least now I can see those 2 points. I know that the red point is actually on the graph, and I know that the green point is absolutely at the center. So I've got a circle, and I know that this from here to here is the radius of that circle. And I want to find the radius. The best way to find the distance between 2 points in general on this test is to make a right triangle. From 5, I definitely went to the right 1. From 3, I definitely went up the square root of 102. So I'd go like this and say, those are the 2 legs of a right triangle. I'd say 1 squared plus the square root of 102 squared equals x squared. And the reason I do that is because I want the vertical line. I want to see this point, 10.149. So 10.149 is the radius of the circle. Now, it happens to be, if you think about it, the square root of 102 squared is 102, and 1 squared is 102. So this is 103. And if you look at this closely, you'll see that this is the square root of 103. Same exact thing. So we know that the radius is the square root of 103. And this is on the outside of the circle, and this is the center of the circle. Now it says ACB. So point A and B are on the actual circle. This is point A. ACB is a right angle. So you went down And then it's like you went 90 degrees and you landed at another point on the circle. If you think about it, this radius is the square root of 103 and this radius is the square root of 103. They're like the two legs of a 45, 45, 90 right triangle. This is the radius, the square root of 102. This is the radius, the square root of 102. The square root of 102 squared plus the square root of 102 squared equals, r squared or h squared, the hypotenuse, c squared here. Ooh, baby, getting close on time. I like it. So the idea is that the two sides are the square root of 103 and the square root of 103. The hypotenuse is the square root of 103 times the square root of 2. The square root of 103 times the square root of 2 is the square root of 206. Funky, funky. An isosceles right triangle with both legs being the square root of 103 and this being the hypotenuse. You could have done Pythagorean theorem as well. That hypotenuse is the length we're looking for because we are looking for the distance from A to B. And so sure enough, it is A. Since we've got 2 questions left and we've got 4 minutes left, I better step this up. So here we go. We've got an electric field passing through a flat surface perpendicular to it. The electric flux of the field through the surface is the product of the field strength and the area of the surface. A certain flat surface consists of 2 adjacent squares where the side length in meters of the larger square is 3 times the side length of the meters in the smaller square. Interesting. So let's say the side length of the smaller square is 3. I don't know. I'll go ahead and say the side length of the smaller square is A. And I'll say that's like A squared is the area of the smaller square. I'll let A be a slider for right now. I'll figure it out later. Then I have a larger square where the side is 3A. So the area of the larger square is 3A squared. Then we have the electric field has a strength of 29. So we know that the strength being 29 times the area of the entire electric field, which is A squared plus 3A squared. That has to be 4640. That is the flux. So I'm going to look for 4640 as I go. All right, A is 4. That's cool. Now what they want to know is they want to know what is the flux of the larger square. So flux is just strength times area of the larger square. The answer is 4176. I'd go a little longer and walk you through that, but with 2 minutes and 34 seconds, I think it only makes sense to go after question 22. Let's see what we've got. All right, we've got a scatter plot, and it's a line of best fit. Then we have a new graph. The new graph is the equation down here, where every y value is multiplied by 3.9. So I'm going to go ahead and say 2, 14 maybe. But then I'm going to take that 14 and multiply it by 3.9 because that's my new data point. Then I'm going to take another point. Let's see, how about 8, 24. 8, oops, not comma, 24 times 3.9. And then I'll go ahead and I'll pick another point. Let's see, 18, 40. So I'll go 18, 40 times 3.9. And now what I want to do is I want to create an equation of best fit. So I'm going to go y subscript 1 tilde, and then I'm going to go a, because I don't know what this point is right here, plus b, because I don't know what that one is either, times x subscript 1. When I do so, sure enough, finding this equation of best fit tells me that A is 42.3 and B is 6.3. This is the closest, 40 something and 6 point something. It looks like I'm good across the board. If I want it to be ultra safe, because now I have an answer. So I don't care if time runs out. I'm good. I've got my answer. I'll pick another point, 12, 31. And when I do, it's going times 3.9. It's going to keep going and hopefully get closer and closer for me, but it will change. 5, 22. times 3.9. Regardless, 47 and 6. I mean, we're clearly in the A category no matter what. I hope this helped you. We just finished module 2 of test 5. This is a harder second module. We crushed it. I hope you feel good about acing it, seeing it all unfold the right way. And I hope you have a magnificent rest of your day. I really hope this helped you. I hope just seeing me do it made you feel great. Have a good one. Oh man, oh man. Just like that. Take it easy, everyone.